June 3, 1944, Southwick House, Portsmouth, England. 4:15 in the morning. The rain hammers against the Georgian mansion's windows with mechanical persistence. Each drop a small verdict against invasion. Inside a wood-paneled library converted to a makeshift command center, Group Captain James Stagg stands before a wall map, covered in isobars and frontal systems. Pressure readings and wind speeds penciled across the English Channel in neat rows. His hand trembles slightly as he lifts his teacup, the china rattling against the saucer. Before him sit the most powerful military commanders in the Western world: Eisenhower, Montgomery, Tedder, Ramsey. They are waiting for him to speak. Not about strategy, not about tactics, about the weather. About whether 5,000 ships and 150,000 men will cross the Channel tomorrow, or wait for conditions that may never improve. The weight of civilization itself seems concentrated in this moment, in this room, in the meteorological calculations of a Scottish RAF officer who looks more like a university lecturer than the man who will choose the hour when the liberation of Europe begins. Stagg clears his throat. The room falls silent except for the rain's relentless drumming. "Gentlemen," he begins, his Highland accent more pronounced under stress. The situation remains unfavorable for the 5th of June. He pauses, aware that each word carries consequences measured in thousands of lives. However, the word hangs in the air like a promise or a threat. Our analysis indicates a potential break in the weather, a gap, 36 hours, perhaps 48, beginning the evening of the 5th and extending through the 6th. Winds will moderate. Cloud cover will lift sufficiently for air operations. Seas will diminish to marginally acceptable levels for landing craft. Eisenhower leans forward. Montgomery remains motionless. The rain continues its verdict against the windows. Stagg knows what they cannot fully comprehend: that this forecast, this prediction of a weather window in the midst of the worst June storm in decades, rests on data gathered by weather stations the Germans don't know exist, analyzed through meteorological understanding the Germans don't possess, coordinated across a network of observers the Germans cannot imagine. The Allies will invade on June 6, not because that date was chosen months ago, but because on this morning, in this room, weather science will overrule military planning, and the Germans will never understand why the story of how Allied meteorologists came to decide the exact hour of D-Day begins not with sophisticated science but with desperate improvisation. In the dark early months of the war, in 1940, as Britain stood alone against Nazi Germany, weather forecasting was more art than science, more educated guessing than rigorous prediction. The British Meteorological Office had perhaps 200 trained forecasters total. Their data came from land stations across Britain, ships at sea reporting when possible, and not much else. Weather moved from west to east across the Atlantic, arriving at British shores with little warning. The Germans, meanwhile, controlled weather stations from Norway to the Spanish border, from France to Poland. They could track weather systems developing over the Atlantic and moving east toward Britain. They possessed superior positional advantage for European weather forecasting. British meteorologists looking west into the Atlantic expanse from their island saw only what their limited observation network could reveal. It wasn't enough. Not nearly enough. Not if Britain intended to fight a war that would depend increasingly on air operations, amphibious landings, and precise timing coordinated across multiple services. The solution began with a simple recognition: weather over Europe originated in the North Atlantic. Whoever controlled information about Atlantic weather patterns controlled forecasting accuracy for the entire European theater. The British couldn't place weather stations in the mid-Atlantic. The ocean was too vast, too hostile, too dominated by German U-boats. But they could do something the Germans could not. They could place weather stations in Iceland. They could recruit weather observers in Greenland. They could establish a reporting network stretching from the Canadian Maritimes through the Azores, from weather ships operating in designated ocean stations to RAF reconnaissance flights that gathered meteorological data while searching for submarines. Most crucially, they could coordinate all this information through a centralized meteorological office that combined observations from dozens of sources, analyzed them using increasingly sophisticated techniques, and produced forecasts far superior to what any single observation point could generate. This was British organizational capability applied to atmospheric science. This was systematic information gathering married to analytical rigor. This was, though no one used the term yet, applied systems thinking directed at weather prediction. By 1942, the Allied Meteorological Network had evolved into something unprecedented in human history. Weather stations in Iceland reported every 3 hours. Stations in Greenland, manned by Danish volunteers and American servicemen, transmitted observations from the Arctic. Weather ships stationed at designated points in the North Atlantic, exposed to horrific conditions and constant U-boat threat, maintained their reporting schedules with obsessive regularity. RAF reconnaissance aircraft flew standardized routes gathering temperature, pressure, humidity, and wind data at multiple altitudes. Coastal stations around Britain, Ireland, and northwestern Europe fed observations into the system. All this raw data flowed to the Central Forecast Office in Dunstable, where teams of meteorologists plotted conditions on massive maps, drew isobars connecting points of equal pressure, identified frontal systems, and projected how those systems would move and evolve over the next 24 to 72 hours. The forecasting techniques were being refined continuously through a process of prediction, observation, analysis of errors, and modification of methods. Each forecast was effectively a hypothesis tested against subsequent reality. Each error revealed something about how weather actually behaved versus how forecasters thought it should behave. The Germans possessed nothing equivalent. They had more observation stations across occupied Europe, but their Atlantic coverage was limited to U-boat weather reports and the occasional armed weather trawler operating in dangerous waters. More significantly, German military meteorology was fragmented across services. The Luftwaffe had its forecasters. The Kriegsmarine had separate forecasters. The Wehrmacht had its own weather service. These organizations shared information reluctantly and incompletely. No central coordination existed. No systematic analysis combined observations from all sources. German forecasting remained localized, short-range, and conservative. This fragmentation was characteristic of Nazi administrative structure, where competing power centers jealously guarded their prerogatives and information sharing was seen as surrendering advantage rather than building collective capability. The same organizational dysfunction that plagued German intelligence, logistics, and strategic planning infected German meteorology. The Allies were building a unified forecasting system. The Germans were running multiple competing forecasting services. When weather became tactically decisive, this difference would matter enormously. The specific challenge of forecasting for D-Day emerged from the operation's extraordinary complexity. Overlord required coordination of naval forces, landing craft, airborne drops, tactical air support, strategic bombing, and ground operations across a front stretching 50 miles. Each component had different weather requirements. The paratroopers needed moderate winds and reasonable visibility. Landing craft needed seas below specific wave heights. Naval gunfire support needed visibility of at least 3 miles. Tactical aircraft needed cloud ceilings above specified altitudes. Strategic bombers needed different conditions entirely. The invasion could proceed only if weather satisfied all these requirements simultaneously across multiple days. Too much wind scattered paratroopers and swamped landing craft. Too much cloud prevented air support. Too much rain turned inland areas into impassable mud. The weather window for Overlord was extraordinarily narrow, and weather in the English Channel in early June was notoriously unstable, dominated by fast-moving low-pressure systems that brought wind, rain, and heavy seas with little warning. Planning for Overlord initially focused on selecting a date based on tidal and lunar requirements. The landing needed low tide to expose German beach obstacles. It needed moonlight for the airborne operations the night before. These requirements limited possible invasion dates to a few days each month. In May 1944, Eisenhower selected June 5th as D-Day with June 6th and 7th as alternatives if weather proved unsatisfactory. The decision seemed straightforward. If weather on June 5th met operational requirements, invade. If not, postpone to June 6 or 7. If those dates were also unsuitable, postpone until the next lunar or tidal window in early July. What this planning didn't fully account for was the cascading nightmare of postponement. 150,000 men were loaded onto ships and sealed in assembly areas. 5,000 vessels were marshaled in English ports. The entire invasion force was coiled like a spring ready to release. Postponement meant unloading troops, dispersing ships, maintaining operational security among thousands of men, who now knew the approximate target and timing. Each day of delay increased the chance of German discovery through reconnaissance, intelligence, or simple deduction. Each day of postponement consumed supplies and stressed logistics. The invasion could be postponed, but postponement itself carried enormous risks. In late May 1944, as the invasion force began assembling, weather forecasts looked favorable. Long-range predictions suggested the first week of June would see typical early summer conditions over the Channel. Moderate winds, scattered clouds, reasonable seas. These forecasts, based on climatological averages and general circulation patterns, suggested June 5th would work well for invasion. Then on June 1st, reality diverged from prediction. A vigorous low-pressure system developed south of Iceland, tracking southeast toward Britain. Another low followed behind it. The systems were stronger and moving faster than climatology suggested they should. By June 3rd, the forecast for June 5th looked increasingly grim. Group Captain Stagg and his team worked through the night of June 3rd and the 4th, analyzing fresh observations from the Atlantic network, projecting how the current weather system would evolve, and searching desperately for any indication of improving conditions. What they found was both terrible and offering a sliver of hope. Terrible because June 5th would indeed see dreadful weather across the Channel. High winds, heavy clouds, rough seas. Impossible conditions for invasion, but hopeful because behind the current system, their analysis suggested, a brief ridge of high pressure might move in, providing a temporary respite before the next system arrived. This forecast, this prediction of a narrow weather window opening on the evening of June, and lasting through June 6th, represented meteorological analysis at its most sophisticated and most uncertain. The high-pressure ridge Stagg's team identified wasn't clearly visible in the current observations. It existed primarily as an extrapolation, a projection of how the atmosphere would likely evolve based on upstream conditions and understood weather patterns. The forecast required believing that observations from Iceland, Greenland, weather ships, and reconnaissance flights could be synthesized into accurate predictions of Channel weather 36 hours in advance. It required trusting that British meteorological science had advanced far enough to see patterns the weather itself hadn't yet revealed. Most significantly, it required Eisenhower to bet the invasion on a forecast that went against all observable conditions. On June 4th, as Eisenhower made his preliminary decision to postpone from June 5th to June 6th, the weather outside was abysmal. Rain lashed the windows. Wind tore at the trees. The idea that conditions would improve within 24 hours seemed absurd to anyone looking at the current sky. But Stagg had access to information invisible from the ground in England. He had reports from weather stations in Iceland showing the leading edge of a high-pressure system. He had observations from weather ships in the Atlantic, tracking how the current low-pressure system was moving and weakening. He had data from reconnaissance flights measuring conditions at altitude that would influence surface weather hours later. He had, most crucially, a network of observations that revealed patterns across space and time that no single location could see. This was the decisive advantage Allied meteorology possessed: the ability to know what weather was doing now across thousands of miles of ocean, and to use that knowledge to project what weather would do tomorrow across the English Channel. The Germans, with their limited Atlantic coverage and fragmented forecasting services, couldn't make equivalent predictions. They could see current conditions. They struggled to see coming conditions beyond 12 to 18 hours. On the morning of June 4th, after Stagg presented his forecast predicting terrible weather on June 5th and improving conditions on June 6th, Eisenhower made the agonizing decision to postpone from June 5th to June 6th. The decision was agonizing because it meant keeping the invasion force loaded and assembled for another full day, accepting all the risks that delay entailed, based purely on weather predictions. If the forecast proved wrong, if June 6th brought weather as bad as June 5th, the consequences would be catastrophic. The invasion might have to be postponed until July, with all the operational and strategic implications that entailed. But Eisenhower trusted his meteorologists. More accurately, he had no choice but to trust them, because weather science was the only tool available for seeing into the immediate future. Either the forecast was correct and June 6 would provide adequate conditions, or it was wrong and the invasion would fail before it began. There was no middle ground, no way to test the forecast before committing. The decision to invade on June 6 was fundamentally a decision to trust meteorological science and the observation network that supported it. The scene in Southwick House during the early morning hours of June 5th has been described by multiple participants as almost unbearably tense. Outside, the storm raged at full strength. Rain pounded the roof. Wind screamed around the building's corners. Inside, Eisenhower and his commanders waited for Stagg's final forecast, the one that would either confirm the predicted weather window or reveal it as meteorological fantasy. Stagg arrived shortly after 4 in the morning, exhausted from another sleepless night of analysis. He faced men who had committed to invasion in less than 24 hours based on his previous forecast. If that forecast now changed, the entire enterprise would collapse into chaos. Stagg's report was brief. The high-pressure ridge was developing as predicted. The weather window would open as forecast. Conditions would not be ideal, but they would be adequate for invasion. Winds would moderate to acceptable levels. Cloud cover would lift enough for air operations. Seas would diminish to marginally workable heights for landing craft. The window would last approximately 36 hours before deteriorating again. Eisenhower asked questions, testing the forecast's certainty. How confident was Stagg in these predictions? What could go wrong? What were the margins of error? Stagg answered honestly. Weather forecasting remained imperfect. The forecast could be wrong, but based on all available data and their best analysis, the predicted weather window was real and invasion on June 6 was feasible. The room fell silent. Everyone understood the magnitude of the decision. Finally, Eisenhower spoke. Okay, we'll go. 3 words. The most consequential 3 words spoken in that war, perhaps in that century. The invasion of Nazi-occupied Europe would proceed on June 6, 1944, because meteorological science had predicted a weather window that would open on that day. The fate of millions would depend on whether that prediction proved accurate. The weather window opened exactly as forecast. On the evening of June 5th, as the invasion fleet crossed the channel, winds moderated. Cloud cover remained heavy but lifted enough for aircraft operations. Seas, while still rough by peacetime standards, diminished to heights landing craft could manage. The conditions were far from ideal. Many landing craft crews became seasick. Some smaller vessels struggled in the swells. But the fleet crossed successfully. The airborne drops proceeded, scattered but adequate. The air forces flew their missions. The naval bombardment delivered its fire support. And on the morning of June 6th, in deteriorating but still workable weather, Allied forces landed on the beaches of Normandy and established the foothold that would lead, 11 months later, to Nazi Germany's surrender. The invasion succeeded for many reasons: careful planning, overwhelming force, deception operations, German mistakes. But it succeeded on June 6 specifically because Allied meteorologists correctly predicted a brief weather window, and military commanders trusted that prediction enough to commit to invasion. The Germans, meanwhile, were betrayed by their own inferior forecasting. On June 4 and 5, German meteorological services predicted continued bad weather across the channel for at least several days. They saw the low-pressure system hammering the coast. They lacked the Atlantic observation network to see the high-pressure ridge developing behind it. German forecasters, working with limited data and fragmented coordination, concluded that invasion weather would remain impossible through at least June 8 or 9. This forecast had profound consequences. Field Marshal Rommel, commanding German defenses in Normandy, left for Germany on June 5 to celebrate his wife's birthday and meet with Hitler, confident that weather made invasion impossible in the near term. Numerous German commanders left their posts. Training exercises proceeded in Normandy on June 5th and into June 6th. Alert levels were reduced. When Allied paratroopers began landing after midnight on June 6th, German forces were caught completely by surprise. The weather that had seemed impossible for invasion had arrived, and with it the invasion itself. The contrast between Allied and German meteorological capabilities reveals something fundamental about how the two sides waged war. The Allies invested enormous resources in weather observation, forecasting, and coordination because they understood that modern military operations required accurate environmental prediction. They built systems, organizations, and analytical capabilities focused on weather as a strategic factor. They placed weather stations in remote locations at great expense and risk. They assigned talented scientists to forecasting roles. They developed institutional mechanisms for combining observations from multiple sources into unified forecasts. They treated meteorology as a crucial military capability worth significant investment. The Germans, conversely, treated weather forecasting as a support service. Important but not crucial. Fragmented across competing services, under-resourced, and isolated from the systematic observation networks that enabled accurate prediction. This difference reflected broader contrasts in how the two sides approached warfare. The Allies built integrated systems that combined intelligence, logistics, technology, and operations into coordinated wholes. The Germans built excellent components, tanks, aircraft, individual units, but struggled with systematic integration. The symbolic object that represents Allied advantage in the D-Day weather forecasting story isn't a physical object at all. It's the barograph, the instrument that continuously records atmospheric pressure on a rotating drum. Every weather station in the Allied network, from Iceland to the Azores, from weather ships to reconnaissance aircraft, carried barographs that traced the rise and fall of pressure over time. These traces, when plotted across space, revealed the location and movement of pressure systems. The barograph's inked line became a symbolic representation of something invisible made visible. The atmosphere's structure revealed through systematic observation. German weather stations also used barographs, of course, but the Allies had far more of them, distributed across a much larger area, reporting into a coordinated analysis system. The density of observation points and the systematization of analysis transformed individual barograph readings into a comprehensive picture of Atlantic weather patterns. Each barograph's trace was a small piece of data. Combined, they became knowledge. Combined with analysis, they became prediction. And prediction, in June 1944, became the difference between invasion and postponement, between success and failure. The psychological impact on German commanders after D-Day, when they learned that the Allies had invaded during what German forecasts said was impossible weather, added another layer of defeat to the military catastrophe. The invasion itself was shocking enough. Overwhelming force, careful coordination, success despite formidable defenses. But learning that Allied meteorologists had somehow predicted weather conditions German forecasters missed entirely, suggested a level of technical sophistication the Germans had not credited their enemies with possessing. How had the Allies known? What information sources did they have? How had they analyzed conditions to reach conclusions German professionals had missed? The questions had no satisfactory answers for German commanders who still believed in German technical superiority. The reality was uncomfortable. Allied weather science was superior because Allied systematic thinking was superior. Better individual brilliance couldn't compensate for better organizational integration. More weather stations under German control couldn't compete with a smaller number of strategically placed Allied stations, coordinated through sophisticated analysis. In the months after D-Day, Allied meteorological capabilities continued providing crucial advantages. The Battle of the Bulge in December 1944 hinged partly on weather. German planners launched their offensive during a period of bad weather that grounded Allied aircraft and reduced visibility. They predicted the weather would remain poor for several days, protecting their advance from air attack. Allied meteorologists predicted a break in the weather within 48 hours. Eisenhower delayed committing major reinforcements until weather cleared, knowing that once it did, Allied air power would devastate German forces in the open. The weather cleared exactly as Allied forecasters predicted. Allied fighter bombers tore into German columns. The offensive stalled. German meteorologists had again predicted continued bad weather. Allied meteorologists had again seen the weather window developing. The pattern repeated. Allied forecasting accuracy provided operational advantage that German commanders couldn't counter. The technical evolution of weather forecasting during the war years was remarkable. In 1939, forecasting beyond 24 hours was largely guesswork. By 1945, Allied forecasters could make reasonably accurate predictions 3 to 4 days ahead for specific operational requirements. This improvement came from accumulated experience, refined techniques, better understanding of atmospheric physics, and most crucially, the comprehensive observation network that revealed weather patterns across continental and oceanic scales. The Germans improved their forecasting too, but not as rapidly and not as comprehensively. They remained limited by fragmented organization and inadequate Atlantic coverage. After the war, captured German meteorological records revealed that German forecasters had been aware of their limitations. Internal reports noted the Allies' superior Atlantic observation network. Recommendations called for expanded weather reconnaissance and improved coordination between services, but recommendations couldn't overcome institutional structures and resource constraints. German meteorology remained fragmented and limited until the war's end. The individual human stories behind the D-Day weather forecast add texture to the strategic narrative. Group Captain Stagg carried the weight of his predictions like physical burden. He later wrote that the days before D-Day were the most stressful of his life, knowing that his forecasts would influence decisions affecting hundreds of thousands of lives. His team of meteorologists worked around the clock, analyzing data, debating interpretations, checking calculations. They argued among themselves about how to interpret ambiguous signals in the observations. American meteorologists on the team were more optimistic about the weather window. British meteorologists were more cautious. Stagg had to synthesize these conflicting views into unified forecasts presented to Eisenhower with apparent certainty, even when uncertainty remained high. The pressure was nearly unbearable. And yet Stagg and his team performed brilliantly, producing forecasts that proved accurate enough to enable operational success. The weather station personnel who provided the observations that made forecasting possible lived their own dramatic stories. The men manning weather stations in Iceland endured isolation and brutal conditions. Weather ship crews in the North Atlantic faced constant danger from storms and U-boats. Several weather ships were lost with all hands during the war. A weather ship stationed in the Atlantic during early June 1944 transmitted reports that proved crucial for detecting the high-pressure ridge that created the D-Day weather window. The ship's crew had no idea their observations would influence the invasion timing. They were simply doing their job, taking measurements, encoding observations, transmitting reports every 3 hours regardless of conditions. This was systematic practice elevated to strategic importance. Anonymous service members performing routine tasks with professional competence created the information foundation that enabled commanders to make history-altering decisions. The German perspective on the D-Day weather disaster evolved over time. Initially, German commanders blamed bad luck. The Allies had invaded during a brief weather window that happened by chance to occur during a period of generally poor conditions. As more information became available, this comfortable explanation crumbled. The Allies hadn't stumbled onto a fortunate weather window. They had predicted it days in advance and planned their invasion timing around it. This wasn't luck. This was systematic superiority in an area German doctrine had treated as merely supportive rather than decisive. The realization stung. German military culture prided itself on thoroughness, technical competence, and professional excellence. Learning that Allied meteorologists had achieved something German meteorologists couldn't do challenged assumptions about relative capabilities. Some German officers dismissed weather forecasting as inherently unpredictable, a matter of chance more than science. Others recognized the uncomfortable truth. The Allies had built a better system and operated it more effectively. The long-term influence of the D-Day weather forecast extended beyond the immediate operational success. It established meteorology as a crucial military capability, requiring significant resources and organizational attention. Post-war military planning incorporated weather forecasting as a central element rather than a peripheral support function. The observation networks built during the war became foundations for civilian weather services. The techniques developed for military forecasting became standard practice in operational meteorology. The systematic approach to combining observations from multiple sources and analyzing them comprehensively became the basis for modern weather prediction. The barograph traces from thousands of Allied weather stations during the war years became historical records that scientists still study to understand mid-20th century climate patterns. The legacy was scientific as well as military. Better understanding of how weather works, better methods for predicting it, better appreciation for the strategic value of environmental information. The symbolism of the D-Day weather forecast resonates beyond military history into broader themes about knowledge, uncertainty, and decision-making. Eisenhower faced an impossible situation. Commit to invasion based on weather predictions that might prove wrong, or postpone and accept different but equally serious risks. He chose to trust scientific prediction over visible current conditions. The sky outside showed storm. The forecast said the storm would break. Eisenhower believed the forecast. This was leadership informed by science, command tempered by expertise. It was also profoundly modern, relying on systematic analysis of data to guide decisions affecting millions. The alternative would have been relying on intuition, experience, or simply gambling. Instead, Eisenhower relied on meteorological science supported by the most comprehensive weather observation network ever assembled. The decision worked because the science was good enough and the network was comprehensive enough. It could easily have failed. Weather forecasting in 1944 remained imperfect, but Allied forecasting was good enough often enough to provide operational advantage. The contrast between Allied systematic thinking and German fragmentation appeared across many domains beyond meteorology. Allied intelligence combined sources through systematic fusion. German intelligence remained fragmented across competing agencies. Allied logistics operated through integrated supply chains. German logistics struggled with coordination across services. Allied research and development proceeded through organized programs. German research and development was scattered across competing projects. The pattern repeated. Allied victory came not from individual superiority in any single area, but from superior systematic integration across all areas. The D-Day weather forecast was a particularly clear example, because weather forecasting depends absolutely on systematic integration. One weather station reveals local conditions. A network of weather stations reveals patterns. A network plus coordinated analysis reveals predictions. The Allies built the network and the analysis system. The Germans did not. The result was predictable, though the Germans failed to predict it. By the summer of 1945, as the war in Europe ended and the war against Japan continued, Allied meteorological capabilities had become so sophisticated that weather forecasting influenced decisions at every operational level. Strategic bombing missions were scheduled around predicted weather over targets. Naval operations factored in forecast sea states. Ground operations incorporated weather predictions into planning. The atomic bomb missions against Hiroshima and Nagasaki proceeded on specific dates, partly because meteorologists predicted clear weather over the target cities. Weather had become fully integrated into military operations as both constraint and opportunity. The Germans and Japanese never achieved equivalent integration. They improved their forecasting during the war, but never caught up to Allied capabilities. The gap, opened by systematic Allied investment in observation networks and analytical methods, only widened as the war progressed. In the decades after the war, as veterans wrote memoirs and historians analyzed documents, the story of how Allied weather forecasting enabled D-Day became part of the invasion's mythology. Eisenhower's decision to trust Stagg's forecast became an exemplar of leadership under uncertainty. Stagg himself became a minor celebrity, the scientist whose predictions shaped history. The broader network of weather observers, forecasters, and analysts who made accurate prediction possible remained mostly anonymous, as support personnel usually do. But their contribution was no less significant. D-Day succeeded on June 6, 1944, because 5,000 ships could cross the channel in manageable weather. The weather was manageable because Allied meteorologists predicted when it would become manageable. The prediction was possible because hundreds of people maintained weather stations in remote locations, transmitted observations faithfully, and fed data into an analytical system sophisticated enough to extract patterns from complexity. This was modern warfare's essence: complex operations depending on systematic information gathering and analysis, on scientific expertise informing command decisions, on organizational capabilities as important as individual courage. The German soldiers manning beach defenses on the morning of June 6th never knew that Allied weather stations across the North Atlantic had decided the exact hour they would face invasion. They understood vaguely that weather had played some role in the invasion's timing, but they couldn't comprehend the systematic capability that had allowed Allied commanders to predict and exploit a narrow weather window German commanders didn't know existed. This incomprehension was itself significant. The Germans were being defeated by capabilities they didn't fully understand, advantages they couldn't see clearly. Weather forecasting was just one example. Allied signals intelligence was another. Allied operational research was a third. Allied logistics coordination was a fourth. In each case, systematic organizational capability provided advantages individual German excellence couldn't counter. The pattern defined the war's outcome. Victory went not to the side with the best individual components, but to the side with the best integrated systems. 75 years after D-Day, the barograph traces from Allied weather stations in early June 1944 remain archived in meteorological institutions. They show the low-pressure systems sweeping across the Atlantic, the pressure dropping as storms intensified. Then the subtle pressure rise as the high-pressure ridge moved in behind. The traces look mundane, inked lines rising and falling on graph paper, mechanical recordings of atmospheric pressure changes. But those lines represented the information that enabled history's largest amphibious invasion to proceed on a specific date. They represented systematic observation, revealing patterns invisible to unaided human perception. They represented science-enabling strategy. The physical barograph instruments themselves, preserved in museums, seem outdated now in the era of satellite imagery and computer modeling. But the principle they embodied remains central to modern life. Systematic observation and analysis can reveal truths about complex systems and enable better decisions. Weather forecasting has improved enormously since 1944. Modern forecasts extend days further with greater accuracy, but the fundamental approach remains the same. Gather observations systematically, analyze them rigorously, extract patterns, make predictions, test predictions against reality, refine methods. This is science applied to practical problems. This is what Allied meteorologists did in 1944, and it helped win the war. The lasting lesson from the D-Day weather forecast isn't primarily about meteorology. Though the technical achievement was remarkable, it's about how systematic capability multiplies operational effectiveness. The Allies didn't win through weather forecasting alone. They won through overwhelming material superiority, better strategic planning, more flexible organizations, technological advantages, and numerous other factors. But among those factors, the ability to predict weather conditions 3 days in advance for a specific location stands out as an example of systematic thinking producing tangible advantage. German meteorologists were skilled professionals. German weather stations collected good data, but German meteorology was fragmented and limited in Atlantic coverage. Allied meteorology was integrated and comprehensive. The difference mattered. On June 4, 1944, when Eisenhower postponed from June 5 to June 6 based on forecasts predicting a weather window, he was betting on Allied systematic superiority. The bet paid off because the system worked. In Southwick House on the morning of June 6, as reports confirmed the invasion was proceeding and weather conditions were holding as forecast, Group Captain Stagg allowed himself a moment of relief. His predictions had proved accurate. The weather window had opened. The invasion was succeeding. He had done his job and history would record the result. But Stagg knew, as all good scientists know, that accurate prediction is never certain. Weather forecasting in 1944 remained probabilistic. Forecasts were educated projections, not guaranteed facts. The D-Day forecast could have been wrong. The high-pressure ridge might not have developed as predicted. The weather window might have closed sooner or never opened at all. If the forecast had failed, the invasion would have failed and Stagg would have carried responsibility for that failure. But the forecast hadn't failed. Allied meteorology, supported by comprehensive Atlantic observation networks and systematic analysis, had predicted conditions accurately enough to enable operational success. Science had served strategy, expertise had informed command, and systematic thinking had prevailed over fragmented organization. The barograph's traced line continues beyond D-Day, beyond the war, into decades of accumulated weather observations that built understanding of Earth's atmospheric behavior. Each observation contributed incrementally to growing knowledge. Each forecast tested that knowledge against reality. Each success and each failure refined methods. This is how science progresses: systematic practice, careful observation, rigorous analysis, continuous refinement. The same process that enabled D-Day weather forecasting enables modern climate science, enables hurricane prediction, enables the weather forecasts everyone checks before planning outdoor activities. The lineage extends directly from 1944 weather stations to contemporary meteorological satellites. The principle remains constant. Observe systematically, analyze rigorously, predict carefully, test honestly, improve continuously. This was Allied methodology in 1944. This remains scientific methodology today, and it works. Not perfectly, not always, but reliably enough, accurately enough, to provide real advantages over those who lack equivalent capabilities. The Germans never knew that Allied weather stations across the North Atlantic decided the exact hour D-Day would begin. They learned afterward that Allied forecasting had predicted the weather window, but they never fully comprehended the systematic network that made such prediction possible. This incomprehension was characteristic. The Germans fought the war they expected: individual excellence, tactical brilliance, operational daring. The Allies fought the war that actually existed: systematic organization, integrated operations, scientific analysis informing strategic decisions. Both approaches had merit. In the long struggle from 1944 to 1945, systematic integration proved more decisive than individual excellence. The D-Day weather forecast encapsulated this reality in miniature. Allied meteorologists weren't necessarily more brilliant than German meteorologists, but Allied meteorology was more systematically organized, more comprehensively equipped with observations, more effectively integrated into operational planning. The system defeated individual excellence, science-informed command. The barograph's inked trace rising and falling with atmospheric pressure across the North Atlantic in early June 1944 recorded the information that enabled invasion, victory, and liberation. A simple mechanical device recording data faithfully, feeding systematic analysis that predicted the future accurately enough to change history. This is modernity's promise, that careful observation and rigorous thinking can reveal patterns and complexity and enable better decisions. On June 6, 1944, that promise was kept. The weather window opened as forecast. The invasion proceeded, and the long march toward victory continued, guided by capabilities the enemy never fully understood and could not match.